Hello, students. Welcome back. This is Mr. Morris. Today, we are going to be working in CAD 226. For those students who are face-to-face, I just gave you a worksheet to help you out with this assignment. However, I will tell you that if you are not face-to-face, no worries. We will post the final product in Canvas, so you will see what it looks like, as well as this video that I'll post later this evening. Without the main purpose of this assignment, a little quieter, please. The main purpose of this assignment is when you're doing CNC programming, you have to create a setup sheet. Mr. Morris, what is a setup sheet? A setup sheet is when you select desired tools that you're going to need. Just by a guess here, how many tools you think we would need for this assignment we're getting ready to do, to machine it? How many? Let's say we give you the piece of round bar. We already give that to you, so you don't have to worry about machining out the round bar. But what type of tools would you need to do everything else? Well, you would use the lathe to face off the both sides and put the chamfer on there. But what about the other four holes? How many different tools you think you would need there? All right, you say 4. Anybody else? All right, let's think about this. All right, let's say you've already given the blank. Let's forget about the lathe work, okay? That has to be done as well. So the lathe work does have to be done. But let's forget about that just for a moment. Let's say you have to just do those 4 holes. You might want to write this down. The first tool that you would have to use would be a center drill, right? Here's why. The center drill is going to do what? It's going to locate the center of the hole, the center drill. I know Professor Rollins has what? Has he shown y'all what a center drill looks like? I think he has, where he made like a little indentation. He drilled a little like a center point, and then he came back and drilled the holes out. None of y'all have seen that? I know he did it on a couple of things. All right, well, if you haven't, that's okay. So what we're going to do is tool number 1, you might want to write this down, because we're going to put it on our drawing, as you will need a center drill. With the exception of the lathe work, you need a center drill that's going to drill all 4 of those locations. It's like when you use a center punch, right? When you do the manual stuff, it's very similar to that. But we're going to say we're going to cut this out on a milling machine, on a lathe, but we're going to use the milling machine to do the holes. All right. Now, so you do a center drill. Now you can do whatever you want to, whatever order you want to. Well, let's say we want to do the 1/4-20 hole first. So that's tool number 1. Write that down. Tool number on a piece of paper. Tool number 1 is a center drill. Tool number 2. Let's say we're going to do the 1/4-20 UNC hole. Threaded hole next. Let's say we're going to do that. Okay. You're going to need what first? Can you just drill a hole and start tapping? You need a what? A tap drill first, right? You need a tap drill for 1/4-20, whatever that is. So tool number 2 is what? Tap drill for 1/4-20. Yeah. We're going to recreate this in CAD in just a moment. But again, for quarter 20 UNC, you're going to need a tap drill first. Now, something you may not be aware of, did you know that you can actually tap a hole with a CNC machine? You can tap a hole with a CNC machine. You can. Hello, it's too much talking. I can't compete with this. Not today. Mr. Morris feels too bad they compete with this. All right, so you have a tap drill. You drill out the hole, and guess what? They have a tap that automatically does this. Everyone look here for a second. You know how you turn it a few times, you back it off manually? Well, with a CNC milling machine, it's a floating head. It floats, right? And it goes a few turns, then automatically backs up a few turns. Then it goes down some more, backs up some more, and it's got a floating head. And there's a coolant being applied, which is continuously washing the chips away so that you don't do what? So you don't want to break the tap. And you need some, probably you'll never do that here at the school here. When you get out in the working world and they teach you how to operate their CNC equipment at wherever company you go work for, you will know that tapping with the CNC machine is very tricky, okay? But it automatically does it for you. It backs off, it turns a few times and it backs off, breaking the chip, and the coolant is continuously washing the chip away. All right, that's hole number one. What about the next hole? Let's say we're going to do the counter bore hole next. All right, so tool number one was what? Center drill. Tool number two was what? Tap drill. What is tool number three before we get away from that hole? The tap. Tool number three is the tap. Now we're going to move over to the counter bore hole, which is the hole at the 12 o'clock position. Now, you've never used one of these before, but you have to have what they call a pilot drill first. A pilot drill. Pilot drill provides clearance for the counter bore tool. The fourth tool is a pilot drill for the counter bore tool, which comes next. So you're drilling a hole all the way through with this pilot drill, which provides clearance for your counter bore. And you'll see it, because one of the things I'm going to have you do in addition is I'm going to have you take a Word document and go and research these tools and paste the image of the tool on the Word document and put it in order. Say tool number one, go find a picture for the CNC machine. Not manual machining, but go find a tool. Now they could be very similar looking, but go find a tool for each one of these tools. It doesn't have to be the exact size. It does not have to be the exact size, but I want you to research what that tool looks like. All right, so you're going to do a pilot. That's tool number 5, right? Let's see, we have the center drill. You're right. It's number 4. I'm sorry. Then we have the counter bore tool. The counter bore tool comes next, and it's going to make the counter bore hole. Okay. Then let's say we go to countersink. Again, you're going to drill somewhat almost like a pilot, and then you're going to come in with a countersink tool, and you're going to make the angled, the recess. Well, it's not a recess. It's actually has an angled, beveled edge to it so that your flathead screw can fit flush with the surface. Okay. How many of y'all ever seen a flathead screw before? You have or have not? Okay. Well, that's a countersink tool. So you first got to drill a hole, and then you follow that hole with the countersink. What size drill do you do first, though? If you look at that drawing, the smaller hole is 0.27. See that the diameter is 0.27 and it goes a 1/2 inch deep, right? Then you come back with the countersink, which has a diameter of 0.51 at 82 degrees. So how many more tools there? 2 more, right? You have, yeah, you have the drill for the countersink drill, and then the countersink drill. I hope you're writing this. Then you go over and you drill the what? You drill the reamed hole, but you have to drill it first, and then you ream it with the reamer. So how many total tools do we have now?
6.
There's about 6.
Center field, top field, top, pilot.
I thought we had 5 when we got done with the counter bore. What tool number is the counter bore? Is it 4? I think it's 5, right? That's right. We're going to do this again on our CAD drawing. This is very important because guess what? You have a lot of tool changes. You have a lot of tool changes with this CNC program.
So there's 5 tools.
After the counter bore, right? And then we had 2 more for the countersink, right? Is that 6 and 7?
6 is countersink.
That's the through hole part of it. That's the countersink drill, and then you have the countersink that follows it.
So number 7 is countersink.
I can't hear what?
Number 7 is countersink.
I think so. We're going to do this again. Yeah, I think there's 9 total tools. We're not done yet. With a reaming, with a reamed hole?
So reaming is 8.
Is reaming 8? How about the hole you have to drill before?
Isn't that the countersink?
No. The countersink is at the 6 o'clock position. Look at the draw. I'm at the 9 o'clock position. At the 9 o'clock position, what are we doing there? We got to drill a hole and then come back with a reaming tool to ream it. Quan, how many tools we got? Now, can you imagine writing this program? Can you imagine writing this program? Hello? Writing this program, it seems like a very simple part. And for all intents and purposes, it is. Pardon?
What's number 8?
You have the count, you have to drill with the you have to drill out the hole for the reamer. And then you come back with a reaming tool. That's two. Now, what you could do, look at position 6 and position 9 on this drawing. Do you see anything similar? Has the same through hole, which is 0.27. So guess what? You could probably just count that as 1 tool, drill both of those holes first. We're going to come back and look at this later. We're going to come back once we start putting on the drawing, and I'm doing it at the same time you are. It will make more sense, okay? All right. So let me go ahead and open up Inventor. File. Okay. I got to share my screen though first. Y'all about let me do that again. I can't forget to share my screen because then the good folks online don't have anything to go by. We're going to go to File, New. This is an English part, so select English. What are we going to select next? What do we select after we select English? Standard IPT. Then what do we do next? Select, create, right? All right. I'm just hoping y'all are learning something from this. By the way, y'all could get y'all a CAD job if everything else falls through. You have the experience to do some CAD work. Go to Start 2D Sketch. Start 2D Sketch. And I want you to click on the XY plane. All right. Now what I'd like for you to do is go to Circle, Circle Center Point, and I want you to click at the origin, and I want to drag out the circle. How big is this circle in diameter? Can you tell by the drawing I gave you? 2.5. Select Enter. You can zoom out some if you want to. Do a right click, select OK. All right. So we got this circle here, 2.5 inches in diameter. We're going to finish the sketch. Going to zoom out some. What am I do now? Extrude. Do I want to go that way? You know why I never go that way? Because I want this surface to be Z0. That's why. I always want this surface to be Z0. How thick is this part? 1/2 inch. Very good. So we're going to put 0.5. Select OK. Now what we're going to do is we're going to, we can go ahead and select our material, go over to the, hang on for a minute. Go over to the browser, right? But you see, we haven't saved it yet. This part, that's a generic name for the file. So do a file, save as, and use all capital letters here. We're going to save this as bolt underscore hole underscore circle bolt underscore hole underscore circle. Save. Notice when you save it, what happens on the top of the browser? Yes, now the changes the file name, right? Do a right click on that and go to iProperties. Go to physical and go to material and select the material you wish. Mr. Morris is going to select steel alloy, apply, close. We might be working with aluminum, okay, when we do this part. Now, very good. What's the size of the chamfer? Right, so we go to chamfer, we're going to type in 0.06 is what we're going to type in. And we're going to select that edge right there, just one edge. Select OK. Now, as we were saying earlier, all this could be pretty much made on the lathe, okay? All this could be pretty much made on the lathe. And you could also do the drilling on the lathe too, but we're gonna think about milling machine right now. We take this part off the lathe, then we put on the milling machine, or the CNC milling machine, I should emphasize here, and we're going to actually drill the holes and stuff. So go to Start 2D Sketch, and click on this face right here. What size is the bolt hole circle itself? 1.63. So 1.625, okay? That's the right answer, but it's 1.6, 1 5/8, 1.625. Enter that, do a right click, okay. Now what I'd like for you to do is I would like for you to go over here where it says point, select point, come to the 12 o'clock position where that circle is, make sure you feel the snap. It will snap to the intersection of the y-axis and that circle. You'll feel it. Click. Do a right click, okay. Now, if you zoom in, it's hard to see, but it's there. See right there, if you hover, you'll see the point. All right, now what I want you to do is go to Finish Sketch, and I'd like for you to go to Hole. I'm gonna slow down just for a second here. I clicked on Hole. Raise your hand if you're not with me. You guys will be remembered as my class that didn't talk. The class I had before you, they talked their heads off. I think these folks up here can get them run for their money. All right. We're gonna do a counterboard hole. Joseph's got it going on. He turns in good CAD work, but
Is the point on the 12 o'clock?
Yeah, Justin, you're so funny with me.
No, that's a shame.
Yeah, right?
Come on, man. Take it easy on the rest of it.
all right. Yes, we are at the 12 o'clock position. See my hole right here at the 12 o'clock position. Now, it's not a threaded hole. Go ahead and just select simple hole. Select simple hole and then come down to seat. We're going to do counter bore right there. All right. Now, we want this to go all the way through, but look, this is not what we want here. We have to modify this somewhat. Sorry, I meant counter bore. I went over too far. This is the one you were supposed to select. My apologies. All right, so you select simple hole, you select counter bore. Okay, and I select through all because I wanted to go all the way through my block here, my cylindrical block. Or it looks like a puck, right? It looks like a puck. Let's give some diameters here. If you look from the drawing, what do you think this diameter, it tells us right there on the drawing what this is. Point what? Well, that's the one that goes all the way through.
0.44.
0.44. What is the depth of the counter bore? See the little depth symbol there? 0.28, that's the depth. Look, put 0.28 right there. And what is the diameter of the through hole? It gives you another diameter. You said it earlier. 0.28. And the reason it's giving me a warning flag is because I got this. You don't need to put the units in there. You can. Okay, say okie dokie. There you go. Do you have a countered board hole now? Now, what's the purpose of a countered board hole? You can recess the what? The head of the bolt or screw. All right. We got that one done. Now we're just modeling. I can't talk this more. We're just modeling this right now. But when we start doing our drawing, that's when we're going to list our tools and tool numbers. All right, go to Start 2D Sketch. I wish I could do all the 4 holes at the same time, but I can't because they're all different. Go to Start 2D Sketch, start 2D sketch, click on this face. Mr. Morris likes to be in the isometric view. I'm gonna go to circle center point. I'm gonna click at the center and I'm gonna drag out 1.625, select enter, do a right click, okie dokie, okay? Now I want you to go to point, come over here, it's gonna snap at the 3 o'clock position, right there. See my point, it's hard to see, but it's there. Do a right click, okay. See if I hover, there's your point, okay? Now what we're going to do is we are going to finish the sketch and we are going to go to hole. And we're not doing counterbore this time. We're doing what? A threaded hole. Look, threaded. Do we have a seat this time? No, there's no seat. In other words, we don't have a counterbore, we don't have a spot face, we don't have a countersink, we have no seat. Now we do want the thread, excuse me, we do want the thread to go full depth, but this is not the size we want. We want, look here, size, arrow down, because we want a 1/4 so select 0.25. When you select 0.25, look, we have the course designation. How do I know it's course? Because it says Unified National Course, UNC. That is not the University of North Carolina like some people have put on the test, okay? So it's a 1/4. Here's the classification of fit. Because you see the letter B, that tells you that it's internal threads. If that's the letter A, that's external threads. And we have, it shows you the threads going all the way through the part. All right. So check what I have here, make sure you have the same thing and select OK. All right. We're getting this done. Now go to start 2D sketch, click on this face. Again, I'm gonna go to circle center point. I'm putting my bolt hole circle in there. It's 1.625, enter, do a right click, okay. We wanna go up here to point. And we want to come down to the 6 o'clock position. You'll feel it snap. You'll feel it snap to the intersection. Click. Right click, okay. If I hover, there's your, your center mark or your point. That's not a center mark, that's just a point. I wish it was bigger than that, but you almost have to have a microscope to see it. All right, so go to finish the sketch. And we're going to go to hole. And what type of hole is this one? Countersink. So we go up here and we're going to first click on simple hole. Okay. And then we're going to come down and we're going to click on countersink. Now, it's going to go all the way through. What is this diameter here supposed to be? Well, let's go to the through diameter. What's the through diameter first? No, the through diameter is 0.27. That's the one that goes all the way through. What is, do we have 82 degrees? See, that's the angle here. See, that's the angle here for the countersink. That's 82 degrees right there. From here to here is 82 degrees. What is this number here supposed to be? I'm gonna let you tell me. 0.51. And I'm happy with that. So I'm going to select OK. All right. Look here, folks. We're getting our bolt hole circle made. We're going to go to sketch. Start 2D sketch. Click on this face. Again, Mr. Morris likes to be in the isometric. You don't have to be. Click at the center. And I'm going to make this 1.625 again. Enter. Do a right click. Okay. Go to point. Go to the 9 o'clock position. And again, you'll feel it snap. Be careful. Make sure you put it in the right place. Right click. Okay. Finish the sketch. Go to hole. This is a simple hole this time. We don't want a seat. And it's going to be a hole that we're going to ream later with a reamer. So what is the diameter of this hole? The final diameter of this would be 0.27. So we don't have to change this. Leave it at 0.27. Say okay. All right. All right, do you have this? I want to do a file and save. Then I'm going to do a file, export, image, file, export, image. We want this to be a PNG file. Make sure you know where to go find it. So when I create a place for you to submit it, you'll be able to. Select okie dokie here or save. So I just saved a picture of this. Going to take a 1 minute breather till you catch up with me. We're going to start making this drawing right here. And it's important. Mr. Morris, why are you making us go through this exercise? Because one day you may or may not be a machinist. One day you may or may not be a machinist. You might be a CAD operator, or you might decide to go on to something more advanced like engineering, which I think a lot of you could do. I really do. But some of y'all, I think, have the love of working with your hands more. So really, I worked with my hands first before I became an engineer, and I was a much better engineer because of it. I'm not saying you can't be a good engineer, but by not doing hands-on stuff, but I think hands-on type of things first helps you realize how things are made, how things are done, how things are built. And then it makes it easier for you when you become the designer of all that as an engineer. All right. Now, what we're going to do, we're going to make a drawing. So we're going to go to File, New. Make sure you select English. Go to ANSI and create. I don't want this sheet here. So I come over here to sheet 1. I do a right click on that and I edit the sheet. I want a size A sheet of paper and I want it to be a portrait and select OK. Go to base. Now, I think I changed the scale to 0.9. I think I changed the scale to 0.9. Select OK. All right, this is going to be our front view, if you will. But do not create your side views yet, because we are going to do section views for our side view and actually, this is going to be our top view. In this case, this is our top view. And it's going to be the parent view because it controls the other views. So I don't know if I've ever told y'all this, but the first view that you place is called the parent view. Here's why it's called the parent view, because it controls the position of the other views. I'll show you here in a minute or two. All right, let's go up here to annotate. Go to annotate. And I want you to go to this one here. It says centered pattern. Click on that. Now you can zoom in. Look, I want you to first click on this outside circle like that. And then I want you to click on the centers of each one of these circles. It'll turn green. Click, 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 right click, create. Did you get it? Okay. That's the center line for the whole circle. Now I'm gonna go back and I'm gonna add center marks for these holes. Right click, okay. You know, actually, I'm not going to. I'm gonna take undo that 4 times. Boom, 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 boom. I'm gonna leave it like that. I think that's perfect. Do you have that? What, Quan, do you have that? All right, now, what I want you to do, we're gonna make some section views here. We are going to make some section views. So, Mr. Morris, how do you do a section view? Go to place view, place views. Come down here with your mouse. It's going to turn a red square around your view. Click on the edge of the rectangle or the square. Or you might have to double click. I'm sorry, I'm gonna try that again. Go to section, come down here, double click. Now, I don't want you to click anywhere. What happens if you hover, you see the little green dot? Hover, just kind of hover, do not select, just kind of hover right there. Do not click and go up and go off the part about right there. Go off the part about right there and do a click. Then I want you to move slowly back across, all the way across the part through the 6 o'clock position, come off the part about the same distance. I want you to left click again, and then I want you to do a right click, continue. And I want you to drag a part over like this. Did you get that? We've done this before, right? Okay. But it's really important for this one because you know why? It's kind of hard to tell what kind of hole. If you do the hidden lines, if you make a view of showing the hidden lines, it could be confusing. It could be confusing, right? So now we're going to do that again. Go to section, come down here and click on that view. Watch, I'm just hovering. I didn't click. Come off in 9 o'clock position about right there. Click, drag your mouse all the way across about right there. Click, do a right click, continue, and you're going to come down here and you're going to place your front view, which is the section view. Do a right click, or just hit escape. Sorry, hit the escape. Now I want to show you something. Remember I said parent view? When I move that parent view around, look what happens to the other view. They follow. That's the children. That's what they used to do. They used to obey their parents. now they don't. I'm just joking. I'm just joking. But you can move this around and you see the children follow, right? Now, we're going to move this up a little bit. We're going to move this over a little bit. Mr. Morris is going to get rid of on our drawing, I didn't change the scale, but I'm going to get rid of the scale. Double click on the view title. Double click on the view title here. And we're going to get rid of the word scale. Select OK. Same thing here, double click on this. Just get rid of the word scale. It's all relative. Select OK. Now go back to projected, right here. We're gonna click, move our mouse so we see the red square, click, and we're gonna put our what? Where we always put it right there. Left click, right click, create. All right. What is this right here called? This is called a cutting plane, right? It's an imaginary cut. And the arrow is the direction you're looking at when you cut it. Put the arrow on top of your head and the arrow, so the arrow is on top of your head and the arrow is pointing in the same direction you're looking. So what are you going to see? You're going to see this right here. Same thing here with the cutting plane BB. You put the arrow on top of your head. Which direction are you looking? You're looking in the direction of the arrow. What do you see when you look at it? You see this. All right. Now let's go back to the isometric view here for a minute. Do a right click and go to edit the view. And we're going to go to style and we're going to select shaded and select OK. All right. That makes it look pretty on the drawing. Now we have some more center lines we have to put in here because we have 4 holes. We have to show the bisector center lines. Go to annotate, please, and select right here in the middle, centerline bisector. Click on that, and I'm going to zoom in. Watch. I'm going to click here, here. I'm going to click here, here. I'm going to click, zoom in here and here. And I'm going to click here and here. All right, I'm going to do a right click, cancel. I'm going to come back to my side view or right side section view. I don't like, if you move your cursor, you'll see the grips turn on automatically. Hold down the left mouse button and drag this. Come down here, hold down your left mouse button and drag that. Beautiful. All right. I'm not going to have you put the titles in, your view titles this time. We might do the one for the isometric. Let's do that for the isometric. And we'll do one for the top. But I'm not going to label the other two because they're already labeled. Go to text. Go on underneath the isometric view. Click. And we're going to type in ISO view. And I'm going to hold down the left mouse button. I'm going to highlight this. I'm going to make it bold. And I'm going to underline. And I'm going to select OK. I'm going to do a right click OK. And I'm going to hold down the left mouse button. And I'm going to drag this around like this. Okay. Now I'm going to copy this. Do a right click, copy. Come down below the front view, right click, paste, and I'm going to paste that joker right here temporarily. Now, you see that A, how it's in my way? You can hold down the A, and you can move it right there. Not hold down the A, excuse me. Hold down the left mouse button. You can move these like this if you wish. All right. Now, that's not the ISO view. You don't want to forget to edit that. Double click on that. And we're going to make that the what? We're going to make that the front view. Select OK. Now, y'all making some good time. Right click or just hit the escape. I'm going to move this up just a tad. Move it over just a little bit. Okay, now we have to start dimensioning this. And it's not really that bad to dimension. It's actually pretty easy to dimension for the most part. By the way, when you're dimensioning something, I try to encourage you to balance out your dimensions. It's almost like you don't want to be too heavy on one side versus the other. Like, for example, here's what I mean. Let me show you something. Just take a break and watch me for a second. I'm doing this because I'm seeing some students do this, and I want to make sure they understand why you shouldn't do this. If I click on dimension, right? Now watch. I want to show you, watch. Watch. I'm going to undo this. I just want to show. You see, do you see what's going on here? You see how cluttered we're getting over here? I always tell students, imagine that being weights, and you're adding weights to that side of the part. It's not going to be balanced. So how can we fix this, Mr. Morris? Well, look here. I could take this one and place it over here. Nice and neat, out of the way, right? I could take this one here. I'm okay with this one. Just leave it right there. All right. You can see I'm running into my side view here, so I'm gonna move this over a little bit. And I'm gonna move my ISO here a little bit. I'm gonna make that smaller here shortly. I'm gonna come back to that. I'm just moving it out of the way temporarily. Actually, the way we got this, it looks like that. All right, go to hole and thread, and click on this. Okay, that looks good. You see how I'm spreading them around? That looks much better, much neater than trying to put all your dimensions on one side. It just looks very cluttered. Go to dimension. We're going to dimension the angle between this line and this line. We're going to drag that out like that. Say okay. Right click, okay. Now, you can see I got to start moving things here. I got to start moving. So I'm going to move this down some. I'm going to move this view down some like that. Now I can go back up here and finish my, put that back in the right place. Now, if you want these labels to roughly be the same size as these here, all you have to do is double click on this, highlight it like this, and go up here and change that to 0.120. 0.120, say okay. Do the same thing here, double click on that, highlight it, do a 0.120, select okay. Again, I'm trying to manage my space here. I'm trying to be very neat, and I'm trying to manage my space. All right. So I can move it down a little bit more now. Say, look, move down. All right, let's see if I'm missing some dimensions. I am. I'm missing the reamed hole. Look here. You got to click here. Now, Mr. Morris, that doesn't say reamed hole. Well, right here in this little dialog box over here, or editor, you can space and you can say, hit the enter key, and below this, you can type in reamed, not reamed, reamed hole. Don't worry about it going off the page right now. We'll fix that. Reamed hole for 1/4. Say okay for that. 1/4 screw. Okay. Now, how in the world are we going to fix that? Well, I can move this all the way over here now. Move this over here some. Hit the escape. You can. I'm going to go back and double click on this. I'm going to put reamed up there, and I'm going to put whole. Yeah, I think that looks good there. There you go. I like that. Now you can move this a little bit closer in. All right. So let's see what let's look at the drawing that I gave you, and let's see what we're missing. So we're missing the chamfer. You have to go to whole and no, you have to go to chamfer note right here. Chamfer note, click on this. Look, you got to first click on the chamfer, then click on this edge, and then you can place your chamfer note right there. Right click OK. Right? Then what we're going to do is we're going to put in a dimension here, here. You see how you got to be careful. My label here didn't move, right? So I'm going to just move it over. I want it to be centered underneath the top. Oh, by the way, what mistake did Mr. Morris made? I made a mistake. Can you tell what it is? It's this view label. What should it really be? Top view. Shame on Mr. Morris. No, there's no shame. There's no shame in making a mistake. All right, I want you to look at what I have on the. Do I have everything I need in order to make this? I do, right? Don't agree with me for the sake of agreeing with me. Just make sure we have all the dimensions covered. That's why Mr. Morris.
I mean, we don't have the,
What did I forget? To the hole on the right. Oh, the depth hole. You don't need it. You know why? Because if you look in the section view, you can see that that hole passes all the way through. So you won't see the depth. You won't see the depth symbol on some of these now because this is actually more accurate. This is more accurate than what we did before. By the way, not that I would ever recommend that you do this, but you can always do that too if you wanted to. You can, but I don't think it looks good. I don't think it looks as good, so I wouldn't recommend it. Do we have everything? Are we missing anything, Lua? Well, we just got to do our title block, right? But the drawing, I think the drawing is done. Except we got to do the title block. Then we're going to go up here, look, in this left-hand corner, Warren, and we're going to, what do you think we're going to do right here? We're going to start listing our what? Our tools. Okay. All right, here we go. Go over here to the browser, right-click on that, go to iProperties, go to Summary, and you're going to say bolt. I think we did a bolt hole circle once before. Subject, CAD 226. The author is you. The manager is me. And the company is Virginia Peninsula Community college. I'm not gonna put anything under this line, but you can write stuff in here if you wish. Go to project, come down to where it says designer, put your last name, engineer, put your last name, authority, put my last name. I was thinking about possibly making this on the 3D printer too. We'll see, maybe not, it might just be a waste of, it would show the different holes though. So that would be cool, show the different holes. Status, go check by you. Okay, click on the check date. Check engineer approved by you. Click on check date. Manufactured approved by me. Check on date. Why do you think I put myself as a manufacturer approved? Because you ain't making it time. I say it's okay. That's right. Apply. Close. File. Save. Save. Now we want to, have I ever shown you how to print this on the printer without a PDF? Okay, here's how you print. Watch carefully. Watch carefully. File. Print. Now, it says the current sheet and model 1-to-1. Go do a preview, and you can see right now that I don't like the way that looks. It needs to be rotated by 90 degrees. Look how big the margins are here, and there's no margins at all here. It needs to be rotated. I'm going to close it out. Watch. I'm going to go to File, Print. Now watch what I do this time. I'm going to rotate by 90 degrees here. Preview. And look how beautiful that is. That's beautiful. Okay. And I'm going to say print. Okay. And you're going to hear the printer go off here in a minute. It's going to print that. Now what I want to do is we want to do a file, export, PDF. Why do we do PDFs? Why do we do PDFs? Why do we do the PNGs? They're easy for me to open and grade, but that ain't the main reason. The main reason is so that you can communicate with people who do not have the CAD program and they can't open it up. They can't open it up. See what I'm saying? So how do you communicate your ideas with other people, other companies? You have to make PDF or PNG. Now, let's say they do have CAD. Let's say they do have CAD. Can we send them the IDW by itself? They can't. Why can't they send the IDW by itself? Because it looks for its cousin, the IPT. They're like they have to go, like bread and butter. They got to go together like bread and butter. You have to keep them in the same directory. If you don't have them in the same directory, it won't create the drawing. You have to keep them always together, the IPT and the IDW. All right, now what I said we were going to do, we're going to go up here and we're going to list the tools. This is not something you would normally do on a drawing. Mr. Morris, why are you asking us to do this? Because I want you to remember there's a lot of things going on here. So basically, list of operations and tools. I'm gonna go below this, maybe hit the space key or enter key twice. One, you're going to, all capital letters, by the way, it should all be capital letters, no lowercase letters. Machine puck, machine puck using lathe. And you can put in parentheses, you know, facing, because you are doing a, actually, yes, yeah. Facing. Mainly you're facing up, because we already got the part. We already have round stock that size. I mean, you really could just cut it on the horizontal bandsaw, but it wouldn't look as nice. I'll get Forrest to cut some out on the lathe for us. Machine puck, or you get you to do it. Machine puck using the lathe, and then we're going to and chamfer, right? So that's the first thing. Now, the second thing is you're gonna put tool number 1, a dash mark. What is it? It's the center drill. By the way, you can, if you want this to stand out, if you want this, just like in Word, if you want it to stand out, underline, you can. Tool number 1 is the center drill. Tool number 2. So we center drill all 4 holes. Then we're gonna go back and we said we were gonna do the tapped hole first, right? This is a tapped drill for 1/4 20 UNC dash 2B. All caps. Again, I'm going to highlight tool number 2 and I'm going to make it bold. Don't worry about if I overlap some of the part. We'll shift things, and if we have to, we can change the size of the text a little bit. All right. After we do a tap drill, what we're going to do now? Tool number. Actually, this is one of the most important assignments I think we've done so far. Tool number 3. It's a tap. I'm gonna put CNC tap. This is not, you're not gonna manually tap that hole. You're gonna use the CNC machine to tap. Come on now, we wrote these tools down. What's the next tool? So right here, we're done with this hole now, right? Because we've drilled it out with the tap drill and we CNC tap. Just another reminder, you will be here next week with a sub. I don't know if you'll be at New Horizons or here. I have another important email I need to share with y'all. Don't let me forget when we get done with this. What's tool number 4? Pilot drill for the counter bore. By the way, you can well, no, just go ahead and write it out this time. Counter board hole. What size is that? By the way, you can type in %% C, type in %% C, and then 0.28. I didn't do it. Hang on. Let me back. Percent C That's supposed to turn into a diameter symbol. Percent C.
It makes a square on your actual paper, if that's what you're.
It shouldn't though. It should be making those. Let's see what happens after we enter the information. If we type in percent C, percent C, 0.28. Go ahead. Let's just do an okay right now. I'm gonna see what happens. That's very odd. Huh? Yeah, they have it up here, but all right. Thank you for, we'll just use that. We can come up here and use it here. Here's the diameter symbol, 0.28. All right, now look, you can move all these notes around, hold down your left mouse button. All right, I'm getting, why do I always forget? Antonio, right? Santonio. Santonio said, I'm always getting y'all's names mixed up still because I'm old and absent-minded, I guess. When you get old, your mind doesn't work as good. All right, look, if you hold down your left mouse button, you can drag these notes around. That's the beauty of that, right? Now, Mr. Morris needs to create, look, I need to create a little bit of room. So I'm gonna come down here, look, I'm gonna come down here, I'm gonna pull this down just a little bit. Be careful as you move things around though, because you don't want to, see here, look, that doesn't look good. Make sure I bring that up some. I'm gonna bring this down a little bit here. Then I'm gonna come up here. Look, I can clear a lot of real estate there with that one. I got room now. I can come up here. I'm gonna delete that space right there. I don't want the space. By the way, if you highlight this, if you highlight that, just like in Word, you can center justification, which I don't like. So just keep left, just keep it as left, make it bold. You can underline that though. So machine puck using the lathe, facing and chamfer. Tool number 1 is the center drill. You can double click on this. How many times are you going to use the center drill? 4 times, right? You're going to go boom, 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 boom. Change the tool. Boom, you come in and drill this hole. Change the tool. You're going to tap this hole, right? Change the tool. All these are tool changes. All right, after we do the pilot hole, what we're going to do next? We're going to actually, tool number 5 is the counter bore, right? Is the counter bore itself. Okay. Tool number 5 is the counter bore itself. All right. What are we doing next? What hole do we say we were going to do? The countersink. Type in 7. And Mr. Morris got to get some water here just a second. Tool number 7, or 6 rather. We're going to drill pilot, drill 4, countersink. And it is equal to what? The same diameter as before. I think. So this is 0.027. Okay, I'm gonna highlight this, make it bold. Yes, you can make it. You can change the scale a little bit. I wouldn't change it too much. What's tool number 7? I thought that was tool number 6.
Oh, okay, never mind.
Am I right or wrong? So number 6 is the pilot drill for countersink. Number 7 must be the countersink, right? All right, very good. You know, there's actually people in this world who have to put all this together, setup sheet. They have to set up the CNC machine to include these tools and the right tool holder. Because you have these tool magazines, you have tool holders, turrets that hold these tools in the right location. And when the program calls them, it goes and picks up that tool. Let's see. Tool number 8. That's the we're gonna drill through hole. For a diameter 0.27. Now, could I have done this with tool number 6? I could have, right? I could already had it knocked out, but I didn't want to confuse you. So it's the same thing, really. It's the same diameter as tool number 6. So we could just, but I'm not gonna. We'll just go back and get that tool again. That's okay. And what's the last tool? Yes. So this is just a little exercise to make you aware that somebody has to set up the machine, put all these tools in the right tool number location. So when your computer program does a tool change, says go to tool 1, it's going to get the center drill. Then it gets done doing all the center drilling. Then it's going to go to tool number 2. It's going to get the tap drill for the 1/4-20. It's going to drill that hole. Then it's going to do a tool change. It's going to go get the CNC tap so you can tap that hole. Then it's going to go do a tool change. It's going to get you the pilot drill for the counterbore hole. And this has a diameter of 0.28. Then it's going to go back and get the correct counterbore, okay, which is tool number 5. Then it's going to put that tool back and get the pilot drill for the countersink, okay. And then it's going to put that back and get the countersink tool to make the countersink itself. And then it's going to go back and do a tool change and go get the drill to for tool number for this hole here at the 9 o'clock position. It's going to drill a hole 0.27 diameter. Then it's going to ream it, and then you're done. And then setup complete. Okay. Now, you see how that's getting kind of congested looking? So all I got to do is take this, move this label down a little bit like that. Then come in here and move this down like that. then you can reposition this however you want. What do you think? It's beautiful, right? Y'all do a beautiful drawing or what? You would not put this on a drawing at all. Right here, these notes. The reason why is because when you give this to a machinist, they're going to set it up the way they want to set it up. So, but this is the preferred way of setting it up. You set up your tools in order in which you're going to use them. Now, there was a couple of places we could have, like that 0.27 diameter hole, we could have did it twice. All right. So I'm going to go and I'm at this point, I'm going to file and save this. And I'm going to file, export this as a PNG or PDF rather, excuse me. Save. Yes. Now, what I'm going to do is I'm going to allow you to print out your drawing today, so you have practice doing that. Go to File, okay, and go to Print. And this is the room number, 1113. You're just going to print the current sheet. Now, you may have to go back and rotate yours by 90 degrees if it doesn't come out right. I've already done that. So why don't you go ahead and check off 90 degrees anyway and do a preview and do a print. Some of y'all ahead of Mr. Morris. And make sure you get the one with your name on it and you can take it home. Uh-oh. You got to rotate yours. You can take this home and show your parents the kind of stuff you do in class, right? All right, I have to go in. I'm going to stop this video and say goodbye to my online friends. It's like romper room. I'm going to end the meeting for all.